All right, so today we'll finish up working with complex numbers. So again, this is A4, which is in the back of the book. Yesterday we looked at adding and subtracting complex numbers. Today we're going to look at multiplying and dividing. So we ended yesterday with this fact. We said I equals the square root of -1. And I said that if you asked me to explain why that's true, what would I say? Why does I equal the square root of -1? Yeah? Because. And if you said, well, how come? I'd say because it does. Okay? I equals the square root of -1 is a definition. It's kind of like if you asked me to prove why parallel lines don't cross. I can't. The fact that parallel lines never cross is just the way you define it. A definition is not something you can prove. It's just you say this is the way it is and you just believe it. That's it. Have faith that I equals the square root of -1. Okay? So if we just accept that as being true, then we can build other facts off of that we can prove. Okay? And this is one of them. I squared. Okay? I squared is going to come up a lot today. And we need to know what it equals. Okay? Does anyone remember from yesterday what I squared simplifies to? Yep, because not 1, close. We're close, yeah? -1. Okay. Because if you think about it, I is the square root of -1. So I squared means to take the square root of -1, that's I, and square it. Well, anytime you square and square root something, they cancel each other out. And all that you're left with is whatever the number was that's under the root. That's why I squared equals -1. So if you get a final answer and you leave I squared in it, I will mark it wrong. Okay? Any answer that has an I squared in it is in the final part. Nope. Should always change I squared to -1. Okay. All right. And that's what I just said. So anytime you do arithmetic, don't ever leave I squared in the final answer. All right, so first thing we're going to do is look at a product. So complex numbers are written like that. Okay, if you weren't here yesterday and you don't remember what they look like, the first number is your real part. The second number is your imaginary part. There is no number in front of I here technically. In a problem like this, now you have a number in front of I. Well, if you don't have a number, what can you always assume that it is? Yep? 1. Pretend like there's a 1 in there. Okay, so that's what a problem is going to look like when we multiply. Now, if you had something, let's go back to this for a second, like this. Does anybody remember the name or how you would multiply that out? A certain property that you have to use here. What is it, you might? Yeah, it's distributive. Some people call it FOIL. I don't know. You've heard that? Other teachers use the word FOIL? Yeah? So you multiply first, outer, inner, last. You do exactly the same thing with complex numbers. Okay? If you had a problem, A, B, C, D would all be numbers. They could be positive or negative. But basically, you do the distributive property twice. Distribute out the A to both. Distribute out the B to both. I should say A gets distributed to both, and the BI gets distributed to both. Now, for those that were here yesterday, I talked a little bit about I. Is I a letter or a number? It's a number. And if you're saying, well, wait a minute, no, it's in the English alphabet. Yeah, it is. It's in the English alphabet, but so is this letter in the Greek alphabet. Well, in math, that symbol that I just put on the board is not a letter. If you're writing Greek, yes, it is, but not in math. Okay, in math, that's like a placeholder. Right? That symbol stands for something. It stands for 3.14. Well, in math, I is not a letter. It's a placeholder. It stands for something. What does it stand for? It stands for the square root of -1. Okay? So when you're looking at a problem like this, there are no letters anywhere in that problem. It's all numbers. Okay. All right, so let's try this one first. So we have 2 plus I times 1 minus I. Now, how do you know this is multiplication? Well, there's nothing between the two sets of parentheses. If I throw a plus sign in there, now it's totally different. That's what we did yesterday. Okay? So look at the problem very carefully before you start it, and make sure you know what you're doing. Make sure you know, is this addition, is it subtraction, or is it multiplication? Usually the directions are going to tell you, but if there ever aren't directions, just look at the problem and read it, and it'll tell you what it is. Okay, so let's go through and distribute and see what happens. So Brady, what would be the first two things I would multiply together?
2 and 1.
Yep. 2 times 1. And Lexi, if I multiply 2 times 1, what do I get? 2. Okay, so there's the first part. Okay, Abby, what are going to be the next two things I multiply?
The 2I.
The 2 and the?
The I. Yeah.
Careful, it's not an I. What is it? It's a.
Square root of negative.
Well, it's square root of -1, but it's. This is an I. This is a.
Oh, negative I.
Negative I. That negative goes with the I. So make sure we remember that. So we have 2 times negative I, which is negative 2I. Okay, Caitlin, next two things I multiply.
I and 1.
Yep. I times 1. And Cassandra, what's I times 1?
I.
Yep. Just a positive I. If you're thinking, could you put 1I? Yep, it's the same thing. Okay, and then the last two things we're going to multiply is positive I times negative I. Well, let's start with the first part. Colby, what's a positive times a negative?
Negative.
Negative. So positive times negative is negative. And Jordan, what's I times I?
I squared or negative.
Yes, I squared, and then in the next step, we need to change that. So we have 2 minus 2I plus I minus, and now I'm going to change I squared to what Jordan just said. I squared is -1. So when I have minus minus 1, what is that really? Yeah.
Just positive.
It's really +1. So I'm just going to make it I plus +1 instead of minus negative. Okay. And now I've got some like terms I can combine. 2 plus a +1. It's 3. So we get 3. And Lauren, what's negative 2I plus I?
3I?
If it was
2I squared.
If it was 2I plus I, that would be 3I. But this is negative 2I plus I. Be the same thing as negative 2x plus
Is
x.
it just 1I, negative 1I?
Negative 1I, yep. And that's your answer, 3 minus I. Okay, when we write an answer, we always put the real part first, the imaginary part second. So the real part here is 3. The imaginary part is a -1. Any questions on how we multiply that? Okay, let's try this one. So we have 8 plus I times 3 plus I. Right, so Tanner, what would be the first two things I multiply together?
8 times 3 and 8 times I.
Yeah, so 8 times 3, 8 times I. Okay, so we got that. Sam, next thing I would multiply?
I and 3.
I times 3, and what's I times 3?
3I.
Yep, just 3I. Okay, and Luke, last two things I'd multiply?
I and I.
Yep. Positive times a positive. Well, first of all, that's going to be a positive. And what's I times I?
I squared.
I squared. Okay, now if we want, we can do two things in this step. We have some like terms we can combine, and we can change the I squared. So let's do both. So Ryan, if I have 8I plus 3I, what would that combine to? 11I. So yeah, 11I plus I squared. So Alan, what's I squared again?
-1.
-1. Try to make my 1's and i's look different because that can get confusing pretty quick. All right, and now that we change that to a -1, we can combine it with what's in front. So Carissa, what would be my final answer there?
24 plus 10I.
Well, careful. You can't combine something that has an I with something that doesn't.
Oh, then it would be 23 plus 11I.
Right, you can combine something that doesn't have an I with something else that doesn't have an I. So 23 plus 11I. Questions on that? Okay, multiplication's important because when we do division, we really have to do multiplication. So if you understand this, you're like 90% of the way to being able to do division. Okay. But before we talk about division, there's one thing I have to mention first, and that's called a conjugate. So let's suppose you had a complex number. I'm going to call it z. And this complex number z that I'm thinking of has a real part and an imaginary part. A is some number and b is some number. Well, there's something that we call the conjugate. And this is the symbol for the conjugate. It's the letter with a bar over it. So z is the complex number I'm thinking of in my head. Z bar is the conjugate of the complex number I'm thinking of. Now, I still haven't told you what the conjugate is. All I've done is shown you the symbol for it. Okay. The conjugate is basically when you just take the sign that's between the real and the imaginary part and you change it. That makes it the conjugate. So to find the conjugate of a complex number, all you have to do is negate the imaginary part. Negate means change the sign of. Just a shorter way of saying that. If that word confuses you, you can just write it out. To find the conjugate of a complex number, change the sign of the imaginary part. And that's it. Okay. So what I'm going to do is I'm going to give you some numbers on the left, and then on the right we will find the conjugate of them. Okay. And if you're wondering why are we finding conjugates, what is this used for, you're going to see in a second. Okay, so let's start with 3 plus 4i. Anyone think they can give me the conjugate of 3 plus 4i? Yeah.
3 minus 4i.
3 minus 4i. Yep. That's it. That's the conjugate. Okay, the next one is -8 minus 2i. What's the conjugate of -8 minus 2i? Yep.
Is it 8 plus 2i, or just say -8 plus 2i?
Well, the directions tell you only to change one thing, right? So, if we follow those directions, tell me one more time, what do you think the final answer is?
It should be 8 plus 2i.
Not quite, we did two things. So the directions say change the sign of the imaginary part.
-8.
Yeah, they don't say to do anything to the real part. Okay, so it's -8 plus 2i. Just like up above. We started with a 3, we ended with a 3. We don't touch the real part. Okay. Right, how about 5i? The conjugate of 5i. Goes on?
-5i.
Yeah. If it confuses you because there's no real part, well then think of it as 0 plus 5i, and the conjugate is 0 minus 5i. Okay. But usually when we have a 0, we don't write it. And how about 3? The conjugate of 3. Yeah. 3. And if you're like, huh, why did it stay the same? Well, think of the one on the left as 3 plus 0i. The one on the right is 3 minus 0i. Whether you add 0 or subtract 0, it doesn't change anything. That's why we don't. Okay, so any questions on finding conjugates? All right, so let's go back to multiplying for a second. And I want to multiply two numbers together, but this time I want to multiply conjugates together and see what happens. Okay. I've got the complex number z, and z in this case stands for 3 minus 4i. Then, if I want to multiply this by the conjugate, first thing I need to do is find the conjugate. What's the conjugate of 3 minus 4i?
3 plus 4i.
3 plus 4i. Okay, let's distribute this out and watch what happens here. So we start 3 times 3. It gives me 9. Justin, what's 3 times 4i? 12i. And then what's 3 times negative 4i? What's 3 times negative 4i? Negative 12i. Look what just happened. Right? Positive 12i, negative 12i. What's going to happen to those? They're going to cancel. And every time you multiply conjugates, that's going to happen. But let's keep going first. Negative 4i times positive 4i. Anyone think they can tell me what that comes out to? Well, awesome.
Negative 16i squared.
Yep. So we got negative 4 times positive 4. That's your negative 16i squared. Now, positive 12i minus 12i. It's gone. Okay. We're left with 9 minus 16 times an I squared. Think about Emma. What did we say I squared equals? That's negative 1. So what we really have is 9 minus 16 times negative 1. Well, 16 times negative 1 is negative 16. And what's going to be my final answer there? Yep? 25. What do you notice about that number, about the final answer? Describe to me what kind of answer that is. Yeah? That's the key. There is no imaginary to it. And every time you multiply conjugates together, that's what always happens. You get no imaginary part. Always end up with a real number. In fact, there's even a shortcut to get to that. Look at this number. If you square 3, what do you get? 9. And if you square just the 4, what do you get? 16. And then if you add the 9 and the 16 together, that's the answer. So with conjugates, you can kind of use that trick to do it faster. It's a waste of time to FOIL it, Because every time you do, you're going to get half the problem canceling out. So why do it if it's just going to disappear in the next step? So let's try that trick here. It doesn't matter which number you use. It's just take the 5 and take the 4. Okay. What do you get if you square the 5? 25? And what do you get if you square the 4? 16. That's the answer to that problem. If you don't like the shortcut and you want to FOIL it all out, you can. Okay, but the shortcut is square the first number, square the second number, and add them up. And if you're like, well, how do I know if I should square the negative 4 or should I do positive 4? It doesn't matter. Negative 4 squared is 16. Positive 4 squared is 16. So it doesn't matter if you use the negative or not. Okay, so here's the shortcut. To multiply two conjugates together, okay, as long as you're following the setup I have up here. As long as A is the real part and B is the imaginary part. Square the A, square the B, not the I, just the A, just the B, and add them up. And that's the answer. Okay, so when I multiply conjugates, I'm going to use that shortcut because it does save us a little bit of time. But if you don't want to and you want to FOIL it out, go for it. Okay. Any questions on what a conjugate is or what happens when you multiply conjugates together? Okay. So the whole point of looking at a conjugate yeah, is because when you multiply conjugates together, it cancels all the i's, and that's something you have to do when you divide. You have to cancel all the i's out. And the conjugate is the way to make that happen. So, to divide two complex numbers, the way you're going to do it is to multiply the top and the bottom by the conjugate of what's in the bottom. Okay, so to divide two complex numbers, multiply the top and the bottom by the conjugate of what's in the bottom. Okay, so we'll do two examples of division, and that will finish up everything in this part. Okay, so there's our problem. We want to take 1, and we want to divide by 3 plus 4i. So the directions say multiply the top and the bottom by the conjugate of what's in the bottom. So what I like to do is put parentheses so I don't forget to distribute. What's the conjugate of 3 plus 4i? Colby?
3 minus 4i.
Yep. So multiply the top and the bottom by the 3 minus 4i. Any questions on that part? Now, the top is going to be easier multiplication than we've ever had to do. It's just a single distributive. Okay? It's not a double distributive. You just have to do that. That's it. Okay? If the top was something like this, then you'd have to go back to what we did before. First, outer, inner, last. Okay? But this one, you don't have to. Okay. When Brady, when I multiply by 1, does that change anything? No. So really, nothing happens here. 1 times 3 is 3. 1 times negative 4 is negative 4i. Now, in the bottom, I'm multiplying conjugates. So I want to use the trick to do it. Can anyone tell me how to multiply those together using the trick we just went over? Oh, paste.
You square the 3.
Square the 3.
4, and you add them together.
Square the 4. And add them up. That's it. Okay, so we're going to end up with 3 minus 4i over, Sean, what's 3 squared plus 4 squared? 25. Now, we're pretty much done, except that's not standard form. Standard form is when you have a real number plus or minus an imaginary number. The real part and the imaginary part are separate. They don't have a denominator like that. So the last thing you have to do to kind of make this in standard form is write it as the real part over the denominator minus the imaginary part over the denominator. So the real part is 3/25, the imaginary part, negative 4/25. That's how you would see a final answer on a test. Okay. Any questions on doing that one? Okay, we'll try one more with division, and then that'll end the appendix review of complex numbers. Okay, so this time we have a complex number in the top and the bottom. We want to make sure that we multiply by the right conjugate. Do I multiply by the conjugate of what's in the top or the conjugate of what's in the bottom? Yep.
The bottom.
The bottom, yes. I don't care what happens in the top. All I care about is I get all the i's out of the bottom. So you've got to use the bottom. Okay, so Nathan, what's the conjugate of the bottom?
25.
What is it?
5.
Well, it's got to be something plus or minus something with an I.
I don't know.
How about Brianna? Can you just remind us how we get the conjugate?
For the bottom.
Yeah, don't tell me what it is. Just tell me how I get it.
Like the new trick we went over, or
Not to multiply, just what we did when we were finding conjugates, when we did this chart.
oh.
How do you find a conjugate?
You change the sign of the imaginary number.
Exactly. All you have to do is change the sign of the imaginary number and then write it down. Okay? So Nathan, if I do that here, could you tell me what the conjugate of the bottom would be now?
Imaginary number would be 12, right?
Right here?
Mm.
Nope, that's a negative 12. But you're in the right area.
Maybe negative 12.
All right, so take this whole thing, write it down again, but change the sign of the imaginary part.
5 plus 12i.
5 plus 12i. Yep. So there's your conjugate. 5 plus 12i, and we got to do it in the top as well. Now in the bottom, I can FOIL this quick. 5 squared plus 12 squared. That's the shortcut. 25 plus 144. Again, if you don't like the shortcut, FOIL it all out, and you'll get exactly the same thing. Now in the top, there is no shortcut. You got to just do the whole thing out the old way. All right. Marisha, can you tell me the first two things I would multiply together?
1 times 5 and
1.
1 times 12i.
Yep. So we got 1 times 5, 1 times 12i, and we'll keep going. Lexi, next two things.
Plus 20i.
Yep. So she did 4i times 5 and got 20i. And Brady, can you tell me what the last term would be?
48.
Close. I like the 48, but a little bit more. 48
I squared.
I squared. What number is 48 I squared? It's really, if we get rid of that I squared, what number would it turn into? That's negative 48. So 48 I squared is negative 48. Okay, so let's combine some like terms. I added up the bottom. We get 169. In the top, I got 5 minus 48. Abby, what's 5 minus 48?
Negative 43.
Yeah. So negative 43. And then 12 and 20 gives me 32. Caitlin, is that okay for my final answer?
No.
No, what do I have to do?
Make it so it's negative 43 over 169 plus 32 over 169i.
Yep. We're just going to split it up. Real part, imaginary part. Okay, now sometimes the question comes up, well, what if you ended up with a fraction like 8 over 10? Would you reduce it? Yeah. Okay. If you could reduce these fractions, you would. But in this case, I don't think you can. Okay. So any questions on dividing complex numbers? Yes?
Wouldn't that be 48I squared?
Yes, 48I squared, and then what's I squared?
You just take 1 off of it,
You multiply it by negative 1.
right? Right.
So it becomes negative 48.
Right.
Yeah. Okay, so remember, it's not a minus 1. We're not going to take 1 off. We're going to multiply it by negative 1. So it changes the sign of it. Yeah, but that's a good question. Okay. Anything else on that? All right. Okay, so last section. As I said, we're not going to get through the whole thing today. We'll get through a good part of it. And the first thing that they show us in this section is what's called the complex plane. So the complex plane is a way to graph complex numbers. Instead of having instead of having an x and a y-axis, we just rename them. In place of the x-axis, we call it the real axis. In place of the y-axis, we call it the imaginary. So graphing something like 2 plus 3i is exactly the same as graphing the coordinate 2 comma 3. You do it exactly the same way. On the real axis, positive is right, negative is left. On the imaginary, positive is up, negative is down, just like you're used to. Okay. So let's start with 2 plus 3i. Jill, what's the real part in 2 plus 3i? 2. So on the real axis, I'm going to go to 2. What's the imaginary part?
3.
3. So on the imaginary axis, I go to 3, and that's it. 2 plus 3i. Very simple. Okay, let's try 4 minus 8i. How about Cassandra? Can you tell me, starting from the origin, how I would get to 4 minus 8i?
4 to the right.
Yep. To the right,
Down 8.
down 8. I think it's right there. Double check, but that looks good. So that's 4 minus 8i. How about negative 8? Where would I go to graph negative 8?
Down 8.
Yeah, we just go, well, actually, be careful. The real axis, that's a real number, right?
Yeah.
The real axis is horizontal.
To the left.
So we're going to go left 8. So we got negative 8. And let's try 5i. How about Jordan? How would I graph 5i?
Well, it would be on
0 on the x-axis.
Yep. It's like you can think of it as 0 plus 5i, so you're not going to go left and right at all.
Then go up 5.
Up 5. Yep. Good. So 5i. The important thing that comes out of this is eventually you're going to have to know how to find out what quadrant a complex number is in. Why are you going to have to know the quadrant? Because eventually we're going to convert complex numbers to polar. And that's the connection we're going to see kind of in a second. So we studied polar before. We studied complex numbers. Now we're going to learn how to write complex numbers in polar. So if you're thinking, why would you ever want to do that? Well, if you write complex numbers in polar, I can make all that stuff I just taught you go away. Division and multiplication become so much easier than that. Okay? In polar, you don't have to do any of the spoiling. You don't have to remember the trick in the bottom, even though it's not hard. You don't have to remember it. You're not going to have to combine like terms. You're not going to have I squared. So you're not going to have to separate this into two fractions. Everything I just taught you goes away, and it becomes much, much easier. Why didn't I teach you that first? Because we don't know how to write complex numbers in polar yet. We don't. We haven't done it. Okay. So I'm going to show you how to write a complex number in polar, and then we're not going to do too much with it today. We might learn how to convert one way, but we're going to save the other way for tomorrow. All right, so suppose we had a complex number. They use the letter z a lot, so I'm going to call it z. And z has a real part and an imaginary part. Okay, and if you look at that, you're like, whoa, wait a minute. Now he's using x and y. He always used a and b when I talked about complex numbers. You can still use a and b if you want. It's just now we're getting into graphing. And I think if I use x and y, you'll remember the real part is horizontal, and the part with the imaginary is the vertical. Okay, that's why I'm using the letters x and y. That form that we've been learning all along, that we call standard form, you can also call it rectangular form. Okay. Why rectangular? Because when you graph it, you're moving on a rectangular grid, or a square grid in this case. Okay. Left and right, up and down. Okay. So now let's look at how we could write this in polar. Now, everything you need to write a complex number in polar, you already know. Nothing changes from what I taught you on Monday and Tuesday. Monday we did real numbers in polar. Now we're doing complex numbers in polar. It's going to be exactly the same thing. Does anyone remember from Monday what the formula was for x? It had an r and a theta in it, and a trig function. Yeah?
Is it r cosine theta?
Yep. So that was the formula for x. And does anyone else remember what the formula for y was? Yeah?
Was it r sine theta?
Yep, exactly. We're going to use those two formulas. And all we have to do to write this in polar is take the x, plug it in right there. So change x to r cosine theta, and change the y to r sine theta. Once we make those two substitutions, we will be converting what we have into polar. Okay, so let's write that out. So x becomes r cosine theta. The I stays right where it is. We don't do anything to the I, but we're going to change the y to r sine theta. Now, if you look in front of the trig function, in front of the sine and in front of the cosine, what do they both have in common? You want to see something that appears twice? Oh, Luke?
R.
R. They both have an R. The first one is r times, then you have cosine theta, and the second one you have an r, again, times the sine theta. Well, whenever you have the same thing written twice, we can factor it out and just write it once. And if you want to check that, distribute it back out, and you'll go right back to what we had. R times cosine theta plus R times the I sine theta. Okay. I'm not going to distribute it back out because I want to leave it like that. And that's the polar form of a complex number. Okay, so what would a final answer look like if you write a complex number in polar? It would look something like this. You would solve for the radius using the Pythagorean theorem, which you learned yesterday. And you would solve for the angle using the inverse tangent formulas that even if you weren't here, I put them on the board at the beginning of the class for you. Let's just make up an angle, 20 degrees. That is an example of a final answer. You don't do anything to that. You don't take the cosine of 20, you don't distribute the 8, you leave it just like that. Okay, so I'm just showing you what a final answer looks like. Okay, so we'll finish up with doing an actual problem. Okay, so we have the number √3 minus I. Okay. Now a little tricky, they didn't put a number in front of I, so what number is always there if they don't put one in? 1. Okay. So there's two things we have to find. You have to figure out what R is, and then you have to figure out what theta is. How do you do that? Exactly the formulas I taught you yesterday. No difference at all. Does anyone remember what the R squared formula was? It was R squared equals yep.
X squared plus Y squared.
Yep, that was one of the formulas. And what was the formula for theta? Anyone remember that one was? Yeah.
Negative the tan -1, and then y over x.
And what's tan -1? I know what you mean. But I just want you to say the name of it.
I don't know. I don't forget how to say it.
She's on the right idea. What's that tan -1? That's exactly what we need, though.
Inverse tangent.
Inverse tangent of y over x. Use the same two formulas you already know. Which one is x and which one is y? I put it right up here for you. The first one is x. The second number is y. The first number is x. The second number is y. And remember, if there's a negative in front of that number, that's a -1. Okay? All right, so let's see what we get. So R squared equals x squared plus y squared. Luke, what's the square root of 3 squared?
3.
3. -1 squared is 1. So my radius squared is 4. So what's my radius? 2. Okay, and that's the first thing I need. Now I know R. Next thing I need is theta. Now, technically theta depends on the quadrant. If you're in quadrants 1 and 4, you use the formula we have right there. If you're in quadrants 2 and 3, what are you supposed to add to it?
180.
You're supposed to add 180. I'm not worried about adding 180 here. How come? That's right and down. If you go right and down, you are in quadrant 4. That's why I showed you how to graph complex numbers earlier, so you could figure out the quadrant you're in. Yeah?
Wouldn't R be 4 if it's 3 plus 1.
R squared would equal 4, but then we have to take the square root. Yep. Okay. So if you graph this complex number, go right, go down, quadrant 4, there's your formula. So let's see what we get. So theta is inverse tangent of -1 over the square root of 3. Don't forget the negative. Okay. And if you're like, well, where does the I go? It doesn't. You don't use the I at all. It just stays right where it is. Okay, so let's see what we get. So second inverse tangent, -1 divided by square root of 3. And I get an answer of -30 degrees. Now, if I wanted, I could make that positive, because what can you always add to an angle? And it doesn't change it, but it'll make it positive. Yeah.
960.
Yeah, you can always add 360. So if you want to leave the answer as -30, that's fine. I like to write polar with positive angles most of the time, but we've talked about how you can do it with negative. But I'm going to write it as positive. Either answer is correct. Okay. So let's go with that one. So now just take the two numbers I have circled, fill them into that formula, and stop. Don't do anything else. So your final answer is R cosine theta plus I sine fill in theta. I sine fill in theta. Now, if you don't follow my directions and you're like, you know what, I'm going to do this out. I'm going to distribute out the 2 and take the cosine of 330. And then I'm going to distribute out the 2 times the sine of 330. What's going to end up happening is you're going to change this problem all the way back to what you started with. So it could be a good way to check your answer if you want. But you stop there for the final answer on the test, just like that. Okay. Now, writing coordinates in polar, just in and of itself like this, really has no purpose at all. Where this becomes super handy is if you want to multiply and divide. It is so easy to multiply and divide these in polar. It looks more complicated, but it's going to make all the stuff we learned today just go away. You're not going to need any of it. Tomorrow we'll see the really, really easy stuff with polars. Okay? All right, so the homework is the last part of 5.6. I'm sorry, Appendix 4 on page 560. It's 15 to 27, odd, and 28. And then on page 333, that's what we just learned at the end, 11 through 19 odd. Okay, so just as a reminder, I will be after school today, so if you need to make up a test or any extra help. And we'll have our second test for the term on Friday. Okay, also, don't forget to check your email for that link to the grading sheet if you want to figure out what your average is for the year right now, and then what if you get a certain grade. I'll also put a link to that in the description of this video.